Man, our Challenger brakes, it's heavy, and the brakes, they just feel a little bit squishy. They're not all there. Our Challenger RT has plenty of horsepower, there's no doubt about it. The Hemi's doing great. The brakes, well, we're lacking in that department. Today on Tech Garage, we're gonna upgrade with all 4 high-performance brakes, and we're gonna give you some diagnostic tips along the way. Welcome to Tech Garage, presented by rockauto.com. Well, we're going plumb crazy today here in the shop, and Brian's already at it. He's taking the wheels off because we're going to do a brake upgrade. Now, this is a Hemi RT shaker. It's a 5.7 liter. It's not a Hellcat, it's not a demon, but it still produces a lot of horsepower. And when it produces a lot of horsepower, you're going to need the stopping power. And fortunately, rockauto.com has just that. They have packages here, which is really cool because I can put everything together in one package. This is a Z26 upgrade brake package by Power Stop, and it all starts right here at the pads. You can see the fiber ceramic pads right here, which is going to be dust free, and on the back you got the stainless steel shims. Comes with all the hardware you need. Once again, a package. Even comes with both calipers, the rear caliper right here and the front caliper. The 2 piston calipers, all new slides. These are powder coated high temperature calipers, which really going to give us some good stopping power. Now the real beauty lies right here in these rotors. These rotors are actually zinc coated for rust, and they're really nice because they're drilled and slotted. The drill is going to help with some heat dissipation, and the slots is going to allow those pads to gas and get it out of there and get the friction material on there for a high coefficient of friction, man. Awesome package here by rockauto.com. But we need to get it on the car, so let's check in with Brian.
Okay, so this is the bottom caliper mounting bracket bolt. I got to get the top one out. I've already got the caliper bolts out, and you can tell by looking at this factory Dodge brake package, it's pretty beefy, but certainly in need of some love and service. There's damage, there's corrosion and heat damage to the rotor. The pads are shot, which precipitated this whole job. We're going to take the opportunity and upgrade that system to the Power Stop setup we've got. So I'm going to get this caliper up off, then the bracket. And for the caliper, we're going to hang it on the bungee cord, one of our fancier tools here in Tech Garage. And we're going to save that as the last step in the project so we lose the least amount of brake fluid. We'll do that all the way around. We'll still have to re-bleed, but we're going to lose the least amount of fluid. So let me get this all buttoned up. It's going to be a fun project. And what you've got to remember is just because it's got pretty paint does not mean it's got performance.
Brian's absolutely right. Pretty paint don't equal performance. So what does? Well, we have to look at a couple of basic brake terms, and one of them's coefficient of friction and brake dynamics. Now, brake dynamics, that's pretty easy. I got my little model here. You're going down the road, you slam on the brakes, guess what? The weight keeps transferring forward. Most of the braking is going to be done in the front, hence our 2 calipers here from Power Stop. You see the 2 pistons in the front right there versus the one in the rear, so we're going to focus there. Also, that coefficient of friction. Well, that's a big word. What is it? Well, we want a high coefficient of friction. I can demonstrate it right here. Sandpaper, as I start pushing it across the table, it's hard to push across the table. That's a high coefficient of friction versus the ice cube. It slides right across. That's not a very good coefficient of friction. Matter of fact, it's very low, and that's not going to do any stopping power. So we want a high coefficient of friction. Well, you can see right here, this is going to be a low coefficient of friction. I got this pad right here that's totally worn out. Brought this into Tech Garage. Now this is metal to metal, and when I'm going around there, I have a low coefficient of friction. But even more importantly, I'm not dissipating any heat. These rotors are big heat sinks as well. So when I'm going down the road, I'm not dissipating that heat. You're boiling back up into the brake fluid. You're getting brake fade. Boom, it's going. You get air in the system. Pedal goes to the floor. It's not a good thing. So like I said, the meat and potatoes are right here, man. We're talking about the drilled and the slotted rotors. Well, what's going on here? Well, the drilled gives us some more surface area to dissipate the heat. You can see the ventilation area right here and the thickness of the rotor. It's used as a big heat sink. Man, this one here, super high coefficient of friction. It's going to do the stopping no problem. Brian's got it underway.
All right, I'm gently just working this caliper up off here. You may have to battle it a little bit. This one's nice and loose. And this paint job, you never know what you're going to find. What is that? Masking tape, it appears, from the paint job on the caliper. They did a stellar job painting, but the masking, well, leaves a little bit to be desired. It is amazing to me that it hasn't burnt off under hard braking. This guy's got to drive faster. Wow. Well, more evidence that we got to do a full-blown brake job here. Hang the caliper up out of the way. Going to try to protect that brake line in the process. Let me get ours over here and secured. And that'll allow me to finish the removal of, let's look at these pads. I'm real curious about this now. So let me work these out. Hard to tell what you're going to find, something like this. Something that's a little did you know. Number one, take a lug nut, put it back on here so you're not wrestling the rotor the whole time like I just was. And when you think about the thermal dynamics of brakes, man, did you know on a 4,000-pound car like this, it takes the same brake horsepower to get it from 65 down to 60 miles an hour as it would from 35 to 0. These things do a really big job. So I feel good about the upgrade that we're going to bolt on. But I want you to see this pad and see what we're really dealing with here. Okay. Well, there's the tape from the paint job on the caliper. Fascinating. Land of opportunity. This car's going to stop a lot better. All right, I'll finish this up. We'll get the rotor off. We're going to clean up that hub face, make sure it's in great shape to receive the new rotor. Remember, calipers last. Stay with us on Tech Garage. We got a break coming up. See what we did there? More Tech Garage from rockauto.com in a minute.
Tech Garage, presented by rockauto.com, is brought to you by Steel Rubber Products, quality crafted rubber parts and weather stripping. Magic Creeper, the most versatile creeper ever. And by rockauto.com, all the parts your car will ever need.
Well, welcome back to Tech Garage, brought to you by rockauto.com. Well, as promised, we've got this pretty well cleaned up with most of the rust and oxidation now gone, creating a really nice marriage and surface area between the new rotor and that assembly. That's important to get maximum braking power. Now, I promised you we'd compare the thickness here between the new rotor and the old rotor. The old one was about 1 1/8 inches thick with the mic. The new one, a little over 1 1/4 inches. Now, those are rough numbers, but it helps you understand there's a lot more beef here. We already talked about the slotted rotor here. We already talked about the cross-drilled rotor. We're making a ton of power. We've got to be able to shed a ton of heat, and that's exactly what this is going to give us. The nice thing about the Power Stop kit that rockauto.com sent us is it comes pre-assembled. The slide pins already lubed for us. We've got everything together, and we've got the new pads already in with the proper lubricant. Here's a look at the new Extreme pad from Power Stop, and there's the old pads. Think we needed a brake job? We're certainly going to be able to stop this thing much better. So my next step is to get the rotor on here. Don't forget, put a lug nut on. Give yourself every possible chance to succeed here. Hold that in place. There we go. All right, now this whole assembly can go up and on. Now here's a little tip. John won't let us do anything in the shop related to brakes on the brackets without the appropriate thread lock. So we've got that just for the caliper mounting bracket. Nothing else. We're going to get this assembly on. Upside down, Brian. There you go. And I'll get these in and, of course, torqued down. And the final step, don't forget, is to transfer the brake line. We're going to do that last so we lose the least possible amount of fluid as we talked about. Now, so far, this is pretty traditional plug-and-play brake job, but there's actually a lot you need to consider when you're doing a total brake system upgrade like we are.
Well, it's been traditional up to this point, Brian says, and you know what? It still is. How do I know that? Well, I'm looking at the caliper. And the caliper actually doesn't have a mechanical e-brake built into it. It's just a normal caliper. That tells me we can push it back. But there is something I want to show you. Check this out right here. This is pretty cool. So if I pull off the rotor, you can see the little shoes inside of here. Now these shoes, that's what the emergency brake is. Inside of that rotor, there's a little surface, and inside of it, it actually touches that surface right there, and that's what does the e-brake. So we don't have a lot of precautions here as far as switching the caliper out. It's going to be pretty cut and dry, almost the same procedure as Brian. But you may run into a car that has a mechanical e-brake built into the caliper assembly. You want to throw up a red flag, you want to slow down. And here's what's going on here. If you look at this caliper, it's actually got the little tabs right here, the little tangs, and those little tangs tell me that this caliper has to be pushed back and turned at the same time or will do damage. So I went to Rock Auto, I got tangs here and the tool to do it with, to push it on rockauto.com, put it in there, line it up, make sure they're in there, and then you can push a little bit of pressure, and at the same time I'll take a wrench and I'll turn this at the same time. So I'm turning, pushing, turning, pushing. I'm not going to do any damage to that caliper assembly, and that's hugely important when you're dealing with that. Now, you may have a caliper that's electronic. That's even bigger because you're going to have some procedure inside the car that has to go through and actually walk the piston back in order to take it off and make sure it's safe to disengage it. Electronic calipers are out there today as well. Well, ours are pretty cut and dry. I took Brian's advice. I went ahead and cleaned up the hub real good. It looks phenomenal. Now all I really have to do is just take our rotor, and they're labeled rear, driver side, because they're directional with the slots here and the drill pattern, and then the caliper assembly. I can take it. Once again, lock tight on the bolts for the bracket, make sure nothing's going to come loose, and get my caliper assembly, slip it over it. Once I slip it over it, I can reach around here and put this on and go ahead and attach the bolts. Make sure it's secure. Let me get it lined up. Oh, my pad popped out. Just be patient. Once again, you got to make sure the pads are all in order. Everything's lined up. There it goes. I got it good. Now I can slip it on there. If it doesn't feel like it's going right, stop. Don't keep forcing it. It's probably not going right, and there's probably something wrong. So you want to go through and fix the process before it's too late, and you do some damage to it, okay? And Brian mentioned the torque specifications. That's huge. You want to make sure you put the proper torque specifications, especially on these caliper bracket bolts, because they have a lot of torque to put onto them here. Line it up back here, get it threaded in. That'll hold it in place for now. I'll come back and I'll secure it. Now it's important that I switch the lines, and when you do that, you have to bleed it. There's a couple ways to bleed it. You can either pressure bleed it, you can vacuum bleed it, which we're going to do, or you can get in there and manually bleed it. Pump, 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 pump. Now, hugely important. Look at this last graphic. It's so important that you actually take the break-in process and you go down the road. What do? Well, just read it, please, the instructions. Don't stop, slam on, and wait, because you're going to cook it and you're going to create a pedal pulsation. You just want to stop with some aggressive stops and keep driving so the system gets cool. Well, I'm going to finish up this, but you can look at Brian's up front. It looks great. It's all together. Torque to specifications. It's going to do some great stopping. You know what? We got Garage Ed right after this segment. We're going to do some starter diagnosing. So we're just getting started here. Stick around. There's plenty more Tech Garage presented by rockauto.com. Welcome back to Tech Garage, presented by rockauto.com. Now it's all about the starter diagnostics on Garage Ed today. And what's better than a whole starter board laid out here where we can see everything? Oh, I know what's better. Tom joined us from rockauto.com. Tom, this is a cool starter system, man. Tell us how it works.
Yeah, you've got everything here. You've got the battery, sends power to the relay, that sends power to the solenoid, that then turns over the starter.
Give it a spin. Works well. Could have voltage drops, though. That's something we want to check with starter systems. Voltage drops are important, Tom, and they can be deceiving. Why do we want to measure voltage drops? Well, you got a good wire there. If you pull that over here, I got our meter set up of ohms of resistance. So if we go across, what do we got there, Tom? About 0.1? Mm-hmm. All right, that's a good wire, wouldn't you say? Sure. What about that? What do you think of this wire?
Not quite as good.
Not near as good. It doesn't look good at all, but yet it's measuring identical, the same thing. Why is that?
Got that little strand of wire there that's enough to conduct some electricity. So.
Exactly. We're talking about continuity. That's voltage drops. We want to actually measure voltage drops because current has to run through there. That'll be a huge fusible link. You can give me a hand. We'll do the positive side first. So what I'm going to do is I'm going to come up to the positive of the starter, and perfect. You're going around the positive cable. You've done this before. Go ahead and run it. Let's see what we got. How about 0.2? That's fine. That's acceptable on the positive side. Now, if we had more, we'd have to go track it. I mean, Tom, you could move over to the solenoid. You want to go to one of them terminals right across there, and I'll go to the other one. And if you want to go ahead and bump it again, we'll look at the meter. We got 12 volts. Go ahead. Not even a tenth, okay? So there's nothing there. Now, if there was, it would be a solenoid issue like this here. These contacts, if these contacts right here are not touching or it's dirty, you know, you got problems with it. You said there's multiple components that can go bad here. Now let's do one more thing. Let's get this off of here and let's look at an amp draw, all right? And this is pretty cool because I got an amp meter right here. I'll spin it over to amps and I'll clip the thing. And Tom, if you'd hold it for a couple of seconds, you're gonna see a big initial hit. And that's nice. So we had an initial hit of about 100 something and then it dropped down. What if I had a mechanical draw on the starter? That's gonna cause amps to go up. What would cause amps to go up on a starter?
Having the engine attached there?
Yeah, that's going to do it for sure. Having the engine attached, mechanical draw on the engine, thick oil, shimmed wrong, something that's causing this thing hard time to spin, that causes amp draws there. Now, the other one is electrical resistance. Tom, I'll tell you what, why don't you get the rockauto.com website set up, and I'll talk a little bit about shimming.
Sounds good.
All right. Now we got an engine over here. Shimming's just as important when you shim an engine because what happens, you put the starter in, it has to be by the flywheel and has to be right. And I'll show you a good demonstration of one that's not. So if I spin this thing right here, watch the pinion come out. First of all, the sound is horrendous. That's not good. And second of all, you can sit there and you can see it spin back and forth. So what you want to do is you want to go get you some shims and you want to put some shims in the starter. Okay, you get a high-pitched sound a lot of times when the key's released, da-da-da-da-da, wing, it's usually too close and you need to get it further away. Now, if it's whining, wah, 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 when you're starting it like this one, it's probably too far away. You want to get it a little bit closer. Good tip for you. If you don't, your flywheel is going to end up like this one right here. You can see it's all eaten up in here. It's all chewed up right there. And that just gets worse and worse and worse, so you want to address that. Shimming it's important. Keeping your starter clean's important. Making sure everything's all right, or you're going to have damage to it. Let's check in with Tom. I think he's got rockauto.com set up and ready to go. Tom, we talked about the importance of shimming it. I mean, you actually offer shims on rockauto.com?
Right, we do. If it worked fine when it was new and then it stops retracting the gear adequately or extending it adequately, then it might be time to get a new starter.
Yeah, and that's huge because the voltage drop is causing that starter, counter electromotive force. There's all kinds of cool stuff going on, but it's getting way too much amperage because it's burning it up. That's what's happening. That's not good. So shims, I mean, just replace the starter, the bearings, the old hammer trick. Remember, bang, bang, bang?
Yeah, make sure your wiring's good, that the voltage, what you just demonstrated. Yeah, you don't want to damage a brand new starter or replace parts you don't need to replace.
Yeah, and we'll tie this in with alternators next week, Tom. Stick around, though. There's plenty more Tech Garage presented by rockauto.com right after this break.
Tech Garage, presented by rockauto.com, is brought to you by Borla, the world's most winning exhaust. Custom Auto Sound, the originator of classic car OEM fit radio since 1977. And by rockauto.com, all the parts your car will ever need.
Welcome back to Tech Garage, presented by rockauto.com. One of our favorite segments, the video question of the week, and man, we got an engine shaking.
Tell you what, Everett's got a misfire, we think, but he's got no check engine light. That's key.
Hey, John and Brian. My engine's shaking a lot. I think it's misfiring and the transmission's bucking. What do you guys think you can do to fix it?
It's a great question, Everett, and I'll tell you what you've got to do next is what we call a power balance test. Short version of that story is you got to check and make sure every cylinder is getting fuel and firing to contribute.
That's it. And you know, we can do it on this car, our Firebird here. We're just going to take the spark away from each cylinder. So I went out and got these fancy tools right here. They go right in line here so I can cancel out the cylinder.
Those are nice, brother, but here's how we would do it in the driveway. It's
Exactly,
paperclip.
yeah, paperclip. There you go.
There
Less
you
than
go.
a penny. So what I'm going to do is I'm actually going to put this in the wire. Well, why am I doing that? Well, I want to create a path of least resistance. So what I'm going to do is actually short out that cylinder. And if the engine starts shaking, then it was contributing to begin with,
That's
Brian.
right.
Now to short it out, we can use this.
Let me ground it over here. Yep. There you go.
All right, so you got a good ground.
Got a good
now
ground.
we'll crank it up in a second. We got our assistant in there, Abante. Abante, why don't you crank it up and watch this? All right, so it's running good right now.
Yep, watch close.
Gone.
Hear that rough idle difference?
Junky.
So that's cylinder one, he's shorting it out.
Right.
It's no longer getting fire. That's why it's running rough. You can do that whether you've got a 4, 6, or 8 cylinder. Do that across all the plugs, and you'll get a validation whether or not you're getting fire.
And it's a good idea to do this. I mean, old school, we used to just pull wires, man. I mean, in the driveway. But
those
today,
coil
the
packs.
module's right underneath
Yeah.
there. Even a distributor with coils in there.
Yep.
You got fire arcing all over the place. We're taking the path of release resistance. Nothing's getting to the cylinder. Started shaking, it's contributing. If it didn't start shaking, it's not firing in the first place. Check that.
Once you validate you've got fire and you still have a problem, it's running rough, you got to check fuel injectors next. You got to make sure you're getting fuel for the fire.
Absolutely. And rockauto.com, make sure you get your spark plugs, your coil, your wires, everything's good. Like you said, it's still misfiring. Injectors, if it's still misfiring, compression time.
Uh-oh.
Yeah. Spark, fuel, and compression, 3 things to make an engine run.
And that's how we get it running and running really, really well. I'll tell you what, the project today was about getting it stopped really well. That was awesome.
It was. I mean, the car stops great, but even better, it even looks good, man. Those drilled and slotted rotors and that paint on those calipers, man, that powder-coated power stop, man, they're great. And that tape, not much
Yeah.
to be desired.
And it's a good thing you don't get to see that clip of the test drive. It's possible that we made some donuts. That was awesome.
It was a great day at Tech Garage, but we're out of time for today. So join us on Facebook, Twitter, YouTube. Keep those questions coming. We may even use yours for a video question of the week. We got plenty of demos in store for you. Join us next week. There'll be plenty more Tech Garage brought to you by rockauto.com.
Production assistance for Tech Garage is provided by Chipola College, located in Marianna, Florida. Founded in 1947, Chipola was ranked recently as one of the top 3 community colleges in the United States.